All right, so now 7, 6, we're going to solve equations. So up until this point, we've just been simplifying radicals, and our answers still contained radicals. But now our answers are just going to be numbers, like x equals 5 or, you know, whatever. So our steps to solving radical equations is first, and I'll follow these steps as I do these problems. So it says isolate the radical if possible. So that means you want to get the radical by itself on one side of the equals. That's done here. We don't have to worry about that second step. So it says raise both sides of the equation to the appropriate power. So if you want to get rid of the radical, what power would you have to raise this to? The second, right? If it's a square root, you square to get rid of the radical. So we're going to square both sides. So the square root of 3w minus 2 squared is 3w minus 2 equals 4 squared is 16. And now we're just going to solve it like we did in the very first chapter we covered. So what would we do? Add 2. So we get 3w equals 18, and then divide by 3. So we get w equals 6. Now, some of these problems, oh, I put a box around it already, but some of these problems, you'll get what are called extraneous solutions that, especially if you get more than one solution. If you got 2 solutions, there's a chance that both of them will work. There's a chance that only one of them will work. There's a chance that neither of them will work. So you should always go back and check your answer in the original. And I'm going to do it every single time in this section. So I get the square root of 3 times 6 minus 2. I want to know if that's equal to 4. 3 times 6 is 18. Yeah, 18 minus 2 is 16. Square root of 16 is equal to 4. So that solution worked. Okay, so the next one, again, the radical is by itself on the left side of the equation. So now we want to raise both sides to a power that will eliminate the radical. So what power do we have to raise each side to? The third. So the cube root of 7m plus 20 cubed is just going to be 7m plus 20. And 5 cubed is 125. And I want to solve for m, so what should we do first on each side? Minus 20. So 7m equals 105, and then divide by 7. And that's m equals 15. And then I'm just going to check it. 7 times 15 plus 20 is 125. And I know that the cube root of 125 is 5. That's right. Okay. The next problem, what's our first step? Get the radical by itself by add 3 on each side. So we get the square root of x plus 5 equals 4. So now the radical is by itself. We're ready to raise to a power. So what power do we raise to? Second. So square root of x plus 5 squared is x plus 5 equals 4 squared is 16, and then just subtract 5. So we get x equals 11, and I'm going to check. So we get square root of 11 plus 5 minus 3, is that equal to 1? Square root of 16 minus 3, yes, equals 1, because square root of 16 is 4. Mm-hmm. Mm-mm. Oh, we'll see some examples. We'll have examples where it doesn't work, so we'll see why. And I'll explain why you might, when it happens, I'll say why. Okay, so here we want to do what first? Add 5 to get the radical by itself. So I get the square root of 1 minus 4x. Oh, Pavel, I'm sorry, what was your question? Nope. Well, then you'd have to do FOIL. So you'd have square root of x plus 5. So if you wrote this out twice, you'd still have square roots left. Okay. Okay, so here adding 5 on both sides, we get 1 minus 4x equals x plus 5. So now the radical's by itself, so we have to do what on each side? Raise to what power? Second, right? We want to square. Square root of 1 minus 4x squared is 1 minus 4x. And here, let's think of doing FOIL. So x plus 5 times x plus 5. So x times x is x squared. What do you get when you combine outside and inside terms? 10x. And then last, 5 times 5 is 25. And now what should we do on each side? Or what do we want? We want, okay, we want everything on one side. Whenever you have your variable raised to a power, you have to get it set equal to 0. We're going to try to solve it by factoring. So you have to have 0 on one side. So I need to subtract 1 and add 4x. So we get 0 equals x squared plus 14x plus 24. So if we can factor it, it's got to be x and x. What are our signs? Both plus, right? Everything's positive. Whoa. Everything's positive. Whoa. And what factors of 24 do we want to use? 2 and 12. And or 12 and 2, doesn't matter what order you put them in. So two things multiplied together equals 0. So either x plus 2 is 0 or x plus 12 is 0. And then we want to solve each of these. So just subtract 2 and subtract 12. Okay, so we got 2 solutions. So this is a case where we really need to check. Normally, when you just get one solution, that solution works. But that's not always the case with 2 solutions. So let's check here. So x equals negative 2. So I'd get square root of 1 minus 4 times negative 2 minus 5 equals negative 2. So that's the square root of 1. So 4 times negative 2 is negative 8. 1 minus negative 8, that's plus 8. So that's the square root of 9 minus 5. That's true. Square root of 9 is 3. 3 minus 5 is negative 2. So I'm going to put a box around that one. Now let's check the other one. So it's 1 minus square root 1 minus 4 times negative 12 minus 5 equals negative 12. Okay, so 4 times negative 12 is negative 48. 1 minus negative 48, so that's 1 plus 48, minus 5 equals negative 12. So square root of 49 minus 5 equals negative 12. What's the square root of 49? 7 minus 5 equals negative 12. Is that right? No. So this one is not a solution. Because then it would not be a function, right? If you said f of x equals the square root of x, and you plugged in 49, and you wanted to say plus or minus 7, then if this is, x equals 49, you'd have a point up here and a point up there, and it's not a function. So square roots are only positive answers. Okay. And that's the reason why we get some answers that won't work. When we square both sides, you would get the same thing if you squared -7 or +7, but the problem is square root can't be negative. So like a lot of times what will happen is one of your answers would work if the square root could be negative, but we can't have a negative square root. So like here, if we were allowed to say square root of 49 equals -7, then it would be true, but we can't. We have to say that the square root is a positive number in order to keep it a function. So that's why you might get some answers that don't work. Now, it wouldn't happen with cube roots, because remember, cube roots, you can have negative answers. So it's not as important to check when you have cube roots or fifth roots as if you had square roots or fourth roots, but it's a good idea to always check. Well, it depends on what happens. I mean, like here, right, this is just going to be one answer, because how many answers you get depends on the sort of equation you end up with after you get rid of the radical. Here we had an x squared, so we knew we could have 2 answers. The only way you could get 3 answers is after you get rid of all the radicals, if you had like an x cubed in there. Okay, so here this problem involves 2 radicals, but it says, okay, if the problem contains more than one, get one of the radicals by itself. Well, in fact, they're each by themselves, but if you just focus on that one, it's by itself on the left. So focus on just getting rid of this one. So we would raise both sides to what power? The third. And that's actually going to get rid of the radicals on both sides of the equation. Because when you cube a cube root, they kind of cancel each other out, and we just get 3y minus 2 equals 5y plus 8. And then what's one thing we should do on each side? Add 2. And then, so if we get our numbers on the right, then we should get our variables on the left. Here we don't have to get it set equal to 0 because the variable isn't raised to a power. So we get -2y equals 10. And then divide both sides by -2. So we get y equals -5. And then I'm just going to go ahead and check. So we get the cube root of 3 times -5 minus 2. Is that equal to the cube root of 5 times -5 plus 8? 3 times -5 is -15 minus 2 equals the cube root of -25 plus 8. Yeah, both of those are equal to -17. -15 minus 2 is -17, -25 plus 8 is -17. Okay, so here we have 2 radicals. They're on the same side of the equation. I have to get one of the radicals by itself. So I might have, instead of moving this one over and subtracting it, I don't want more negatives than I need. I'll add this radical to both sides. So let's add square root of x minus 1 on both sides. So we get square root of 2x minus 1 equals 1 plus the square root of x minus 1. And now focus on the radical that's by itself. So if I want to get rid of that radical, we would do what to each side? Square. Right? The left side is easy to deal with. Square root of 2x minus 1 squared. Just 2x minus 1. But on the right, we have to do FOIL. So 1 plus square root of x minus 1 times 1 plus the square root of x minus 1. Because you would have to do FOIL with these two square roots then. Right? You have to remember, a plus b squared is not equal to a squared plus b squared. You can't square two terms, right? That's really, a lot of people want to do that, so you can't do that. Keep that in mind. Okay, so first, 1 times 1 is just 1. Outside is plus the square root of x minus 1. Inside is plus the square root of x minus 1. And last, so we have plus the square root of x minus 1 squared, since we have square root of x minus 1 times square root of x minus 1. So let's simplify. We can't do anything on the left, but we should be able to simplify on the right. So we have 2x minus 1 equals 1. Now these radicals are similar radicals. They both have the square root of x minus 1, so we can combine them. The answer is going to have a square root of x minus 1. What goes in front of the square root? Plus 2. And then the square root of x minus 1 squared? X minus 1. So we can simplify. Can we simplify more on the right-hand side? Yeah, we can cancel the 1s. But we still have a radical left in the problem. And now we want to get that radical by itself. So what would we have to do on each side? Minus x. So we have x minus 1 equals 2 times the square root of x minus 1. Now you could divide both sides by 2 before to get the radical completely by itself, but if it's only one term, you can leave the number out in front. I would rather not deal with fractions if I don't have to. So if that 2 wasn't there, we would do what on both sides? It's just square. And so we can do that here. We just have to remember to square the 2 as well. So instead of dealing with fractions, I'm just going to go straight to squaring both sides. On the left, we have to do FOIL. So x minus 1 times x minus 1. So first times first is x squared. What do we get when we combine outside and inside? Negative 2x. And negative 1 times negative 1 is positive 1. And 2 squared is 4. And the square root of x minus 1 squared? X minus 1. First, I'm going to distribute the 4 on the right. So we get equals 4x minus 4. Then what do we need to do? Yeah, we have to have it set equal to 0 because there's an x squared. We're going to try to factor. So minus 4x plus 4. So we get x squared minus 6x plus 5 equals 0. So we hope we can factor. If we can, it's x and x. What are the signs? 2 pluses, 2 minuses, one of each. Both negative, right? If the last sign is positive, it's either 2 pluses or 2 minuses. It's whatever's in the middle. And the only way to factor 5 is 1 times 5. Well, I wrote it in. Does that work? Yeah, because outside and inside combine to give us negative 6x. So 2 things multiplied together equals 0, so either x minus 1 equals 0, oops, or x minus 5 equals 0, and then we'll add 1 and add 5. So the original answer involves square roots, and I got 2 answers, I need to check. Okay, so first I'll check x equals 1. So I'd have the square root of 2 times 1 is just 2 minus 1, minus the square root of 1 minus 1 equals 1. Yep. No, what's the square root of 0? 0, right? Because 0 squared is 0. So we have the square root of 1 minus 0 equals 1. That one is true. So this one works. Let's check 5. So the square root of 2 times 5 is 10 minus 1 minus the square root of 5 minus 1. Is that equal to 1? Square root of, square root of 10 minus 1, that's the square root of 9, minus the square root of 4. Yep, square root of 9 is 3, square root of 4 is 2. So this time both of the solutions worked. In the next problem, again, we have 2 radicals. So our first step is to get one of them by itself. And it doesn't matter which one, but since this one has a negative in front, I'll go ahead and add that to both sides. I wouldn't want to subtract something if I could add something. So I'll add square root of x minus 6 to each side. So then I get the square root of 2x plus 6 equals 3 plus the square root of x minus 6. And then now this radical is by itself, so we would do what on each side? Square. And the left-hand side is easy to deal with. The square root of 2x plus 6 squared is 2x plus 6. It's on the right-hand side that it's the hard work. We have to do FOIL. So 3 plus square root of x plus 6 times 3 plus, or x minus 6, sorry. 3 plus the square root of x minus 6. And then do FOIL with that. So 3 times 3 is 9. Outsides give me plus 3 square root of x minus 6. Insides also give me plus 3 square root of x minus 6. And then the last terms are both positive. Square root of x minus 6 times square root of x minus 6 is square root of x minus 6 squared. There's nothing I want to do on the left-hand side, but I do want to simplify on the right. The middle terms are similar radicals. They both have square root of x minus 6, so the answer is going to have square root of x minus 6. What goes in front? 6. And the square root of x minus 6 squared? X minus 6. Can we simplify on the right? Yes, we can combine the 9 and the minus 6. So we get 3 plus 6 square root of x minus 6 plus x. And there's nothing else we can do to simplify on the right, but our equation still has a radical in it. We want to get that radical by itself, at least that term by itself. So I'm going to subtract 3 and x. So 2x minus x is x, plus 6 minus 3 is plus 3, equals 6 times the square root of x minus 6. So now I have the term with the radical by itself, and we should do what to each side? Square. Now it's on the left that we have to do FOIL. First times first, so x squared. What do we get when we combine outside and inside? 6x. And then plus 9. And on the right, we have to square both the 6 and the square root. So 6 squared is 36. And the square root of x minus 6 squared? X minus 6. So on the right, I want to distribute the 36. So 36x minus 216. And now what do we need? Yeah, we want it to be set equal to 0 since we have an x squared. So minus 36x plus 216. So we get x squared minus 30x plus 225 equals 0. Okay, so we hope we can factor this. If we can, it's x and x. What are our signs? 2 pluses, 2 minuses, one of each. 2 minuses. Now we want factors of 225 that add up to 30. I know 5 goes in. Oops, oops. Ooh. So 5 and 45, that doesn't work. So you could go up from 5. And yeah, since it ends in a 5, it makes sense to check other things that end in a 5. So 10 doesn't, but 15 does. Yep, 15 and 15, that makes 30. So that's the same factor both times, so I can just set x minus 15 equal to 0 one time. I don't have to do it twice. And then add 15 on each side. So we get x equals 15, but I need to check my answer. So I get 2 times the square root of 15 plus 6 minus the square root of 15 minus 6. Does that equal 3? So that's 2 times 15 is 30 plus 6, so the square root of 36 minus the square root of 9. Yeah, that's 6 minus 3. So x equals 15 worked. Mm-hmm.
Did you ever kind of like treat instead everything equal to 0 and then try to square it?
You would have to do FOIL with 3 terms in each set of parentheses. I wouldn't call that cheating. You're making it way more work for yourself. Okay, so the next one says it's raised to the 1/5 power. What does that mean, the 1/5 power? The 5th root, right? So this means the 5th root of 6p plus 3 equals the 5th root of 4p minus 9. Well, if you look at, just focus on the left-hand side, that radical is by itself. So what power would you raise each side to? The what? Yeah, 5. Can you do what? You could have done it in the first step. You could have said, okay, let's raise both sides to the 5th power. And then remember, when you have parentheses to a power, you multiply their exponents. And 1/5 times 5 is 1, because the 5's cancel. So you could have done it straight from the rational exponents. Well, 5th root and 5th power cancel each other out. So we get 6p plus 3 equals 4p minus 9. Here, there's no variable squared, so we are not going to have to factor. So we just want to get the p's on one side, everything else on the other. So minus 4p minus 3. So we get 2p equals negative 12. So p equals negative 6. And if I check that answer in the original, So I have 6 times negative 6 plus 3 to the 1/5 equals 4 times negative 6 minus 9 to the 1/5. So that's negative 36 plus 3, so negative 33 to the 1/5. 4 times negative 6 is negative 24 minus 9, which is negative 33. So I have negative 33 to the 1/5 on each side, so it works. Okay, so the next one is geometry formula. So it says that formula gives the radius r of a sphere in terms of its surface area, S, and they have the formula solved for r, and they want us to solve for S instead. Well, this is an equation that contains a radical, so our first step would be to get the radical by itself on one side. It already is. So then, after the radical is by itself, then you want to raise both sides to a power. What power? The third. So we get r cubed equals, what? Yeah, just s over 4 pi. And if I want to solve for s, then what would we do on each side? Yep, multiply by 4 pi. So our answer is s equals 4 pi r cubed. Now, we actually should already know how to graph this next one. So let's actually do part D. Let's graph it first, and then answer the questions A, B, and C, and make sure that they match what we have in the graph. So remember, our regular square root function starts at 0, 0, and then if you plug in x equals 1, you'd get y equals 1. If you plug in x equals 4, you get y equals 2. I'm just going to do a dashed line. This is just f of x equals square root of x. That's the original square root function. If we add 3 under the square root, what does that make us do to the graph? I've heard up, down, and, or I've heard up. I think I have heard everything, up, down, right, and left. So, okay, let's do parts A, B, and C, and then we'll check our answer and see what happens. So part A says solve g of x equals 0. So where does the 0 go? Do we plug 0 in for x? In for the y, right? If they wanted us to plug in 0 for x, they'd write g of 0, right? It's the x that's in parentheses. G of x means y, right? So they want us to plug in y equals 0. So this is the y. So we have 0 equals the square root of x plus 3. And now we want to solve that equation. It contains a radical. The radical is already by itself on the right. So what power on both sides? Yeah, we're just going to square both sides. Well, 0 squared is still 0. Square root of x plus 3 squared, x plus 3. And then to solve for x, we'll just subtract 3 on each side. So negative 3 equals x. So, and then it says what point is on the graph? What's the x coordinate? Negative 3. What's the y? 0. So now what do you think? It moves to the left, right? I mean, correct. It moves to the left. And then part B says solve g of x equals 1. So now we're plugging in 1 where the y would go. And it's the same exact steps we did in part A. The radical's already by itself, so we'll just go ahead and square both sides. 1 squared is 1. Squaring a square root just gets rid of the square root. And then again, subtract 3 on each side. So negative 2 equals x. And then the point on the graph, the x coordinate is negative 2, and the y coordinate is 1. And then the last one, I think I have room to do it here. So g of x equals 2. So we're just plugging in 2 on the left-hand side. But it's the exact same steps. Square both sides. So 2 squared is 4. Squaring the square root just gets rid of the square root. And then subtract 3 on each side. So 1 equals x. So the point, what's the x coordinate? 1, and the y is 2. So if you don't remember the rules about moving left and right, it's not like you're stuck. You can't do anything. You could also make a t-table and plug in points for x. You should get the same graph. Okay. I must have changed margins because the graph was right here and there's not a back of this page. Okay. Okay, well that's our book, Martin Gay. So let's see, problem 62 says a wire is to be attached to support a telephone pole. Because of surrounding buildings, sidewalks, and roadways, the wire must be anchored exactly 15 feet from the base of the pole. So I'm going to start a picture here. So there's a pole. And it has to, when we anchor it to the ground, it has to be 15 feet away from the base. So here's the base of the pole, and then we have to go out 15 feet. And this is where we'll attach the wire. Telephone company workers have only 30 feet of cable, and 2 feet of that must be used to attach the cable to the pole and to the stake on the ground. So 2 feet of that must attach. I don't know what they mean by, I see the stake on the ground. So maybe there's a stake that sticks up and that has to go 2 feet to the ground. If that's the case, if we have to use 2 of it to do that, 2 feet of the cable to do that, how much cable do we have left then? We have 28 feet of cable left. I don't think they mean 2 feet on each side. Okay, so we'll do it both ways. I didn't bring my book with me, but I'll show you how to do it either way. Because if they meant, I don't know if they mean 2 feet, like if they would need 1 foot here and then maybe 1 foot there, if they need a total of 2 feet, or if they need 2 feet on each side. So if they need 2 feet on each part, then we would have to take away a total of 4 feet, so we'd have 26 feet left. So we'll do it each way. So it says, how high from the base of the pole can the wire be attached? So actually they must just be doing it straight across. So the cable is going to go from here to the pole. And if we assume we had 28 feet of cable left, then this would be 28 feet. And we're trying to find how high that is. Well, if we're going to write an equation, we need to define a variable. They haven't done that for us. So we would let h equal the highest point of attachment on the pole. Well, what's special about the picture we've drawn? It's a what? It's a right triangle. So we can use the Pythagorean Theorem. And remember, for the Pythagorean Theorem, it's leg squared plus leg squared equals hypotenuse squared. So which one is the hypotenuse? the 28, right? And it would be, if we had done it the other way, we'd have a 26 there. So then one leg is what? 15, and the other leg is the one we don't know that we called h. So 15 squared plus h squared. So that's 225. 28 squared is 784. If we did it the other way, we'd get 225 plus h squared equals 676. In either of those equations, we're wanting to solve for h, and so we'd have to do what on each side? Subtract 225. So h squared equals, in the second one, we'd get 451. In the first one, we get 559. So if we want to solve for h, what would we have to do on each side? Square root. So they say first find an exact answer and then approximate to 2 decimal places. Okay, now these would be exact answers. I'm not quite done because I need units on there. Square root of 559 what? Feet. The other thing you need to do is see if either of those simplify. So I want to see if there are any squares that go into 559. 4 is not going to go in there. 9, 5 plus 9 is 19. That's not a multiple of 9. 16 is not going to go in there. 25 won't. 49, nope. And notice when I tried 49, I got a number that was pretty small, 11. So now it's going back to numbers that I've kind of already, it's smaller than numbers I've already checked in my head. So you don't have to go any farther than that. So that one won't simplify. And then it says, and approximate to 2 decimal places. So we just do that on our calculator. Square root of 559 is about 23.64. If we had done it the other way, assuming they needed 2 feet on each part, we'd have 451. 4 is not going to go in there. 5 plus 4 plus 1 is 10. That's not a multiple of 9, so 9 won't go in. The next square is 16. That's not even. 25 doesn't end in 5 or 0. 49. Yeah, so that one's not going to simplify either. So we can just leave it like that. And then square root of 451 is about 21.24. Okay. One more problem. If you got your answer wrong, if there's one like this on the homework, the first thing I would do is if you weren't sure what they want, right away your first try use the help me solve this. They'll tell you what they mean. They'll draw a picture for you. So I would say, that, I mean, that uses one of your 5 attempts, but then at least you know what they want you to do. I wouldn't try it both ways. I would immediately use help me solve this. Okay, problem 66 from the book. So it says 2 tractors are pulling a tree stump from a field. If 2 forces A and B pass at right angles or 90 degrees to each other, the size of the resulting force is given by this formula, and they tell us how much force tractor A is exerting and how much force tractor B is exerting. So like here's the tree stump, and then tractor 1 is pulling this way, and then at 90 degrees maybe tractor B is pulling this way, and it looks like tractor B is pulling a little bit harder. 850 pounds of force. And tractor A was just 600 pounds of force. Oh, we're supposed, okay, we don't know how much tractor B is. Okay, find how much force tractor B is exerting. Okay. Yeah, yep, that would be, except for the thing is it's not gonna look like that. You want it coming from the tree stump. So this is gonna be 850, but then you can think of, you know that this part is 600, so what's that? And they give us the formula anyway. So the 850 goes in for which letter? The R. Square root, and then A is 600 squared plus, and then we're trying to find B. 600 squared, well, 6 squared is 36. And then if you have 2 zeros and you're squaring, you're going to end up with 4 zeros. You can do it on your calculator, though, too. Plus B squared. Right. If it was just the square root of B squared, yeah, you could, but not when there's a plus in. So now we have an equation with a radical, and the radical is by itself on the right-hand side, so we're ready to get rid of it, and we raise each side to what power? Yeah, the second. So 850 squared is 722,500, and the square root squared, that just eliminates the radical. And then what would we do here? Yeah, subtract that 360,000. So 362,500, and then B, how are we going to find B? Yeah, we take the square root, and we'll do the same thing we did with the last one. We'll find an exact answer, and then we'll get an approximation. What are the units on this? Pounds. Okay, the first thing I know I can do is, since it ends in 2 zeros, 100 goes into it. So it's 100 times 3625. And what's the square root of 100? 10. I can take out a 10. But if it ends in 25, 50, or 75, 25 goes in. So if I do 3625 divided by 25, I get 145. So I can write 3625 as 25 times 145. And then what else can I bring out in front of the radical? 5. So we have 10 times 5, and then 145. Well, I want to know if there are any squares that go into that. I know 5 goes into it. It's not a square, but I can at least see what other factors go in. No, it's just 5 and 29, and you can't factor 29 at all. So the 145 would have to stay under there. 10 times 5 is 50. So here's our exact answer. And if they ask for an exact answer, then you have to simplify as much as you can. If at the very beginning they said just approximate your answer to the nearest whole number, I wouldn't have even bothered going through simplifying. I only go through simplifying if they ask me for an exact answer. If they're going to ask you to use your calculator anyway at the end, why not just use it at the beginning? Okay. So if they had just asked for an approximation, and I'll say, oops, I'll just say the nearest whole number this time since these are pretty big. And we'll make sure we get the same answer either way. Square root of 362,500 is about 602. Now if we did it this way, 50 times the square root of 145, yep, you get the exact same answer.